Okay, so we're going to continue on to the second part of mechanics. The first part that we learn is kinematics, which dealing about the motion of the object. How far would it go? How fast would it be? How long would it take? Now, the second part will be dealing with why. Why the object move in that particular way? And of course, the answer is going to be about the forces. Because there is a force like that, so it causes the acceleration. Okay? So the forces, and of course, Newton's law. You probably have heard of that guy, right? Sir Isaac Newton. He figured out the law of motions, and we're gonna look at what are they. But first thing first, let's look at forces. So the question is, what is forces? It seems like an easy question, right? It's just a simple question of what is a force. Now, the good thing about force in physics is that it's the same as the force in typical daily life. So a typical force, usually I think of it as a push or a pull. Like you push something or like you pull something. Now, the very simple case of a force is you push a door. Like maybe you want to open a door, you push a door or you pull the door. But let's be a bit more sciencey, okay? The force, I think of the force as an interaction. I think of it as an interaction. That one object acts on another object. Okay, so this is actually a very important point. Force is something that one object acts on another object. For example, if I want to push the door, I'm the one who pushes on the door. Okay, so there will always be two objects involved, the one who create the force and the one who get acted on by the force. Okay, always. And whenever we talk in the future of the forces, you need to be careful. That force, who is the one who created and who is the one who get acted on by it. I push the door. I pull the door. I push on the table. Or maybe the table pushes on me. That is a weird one, but it actually could happen. So force always an interaction that one object acts on another object. Now let's think. Let's say I push a door, when I act on the door, that force is gonna cause the motion on the door, right? It's gonna make the door move in a certain way. And that's the key. When we want to look at the motion of any object, how would it move? We need to look at the force that is acting on it, not the force that it acts on something else. For example, let's say if I have a box and I want to see how the box moves, like which way would it go, then I need to consider the forces that act on the box, not the force that the box acts on the other thing. So that's the key. You need to be careful of what force is acting on what object. Okay? So we're gonna start simple. I'm gonna start simple by telling you about the common forces. The common forces, as the name pretty much suggests, is a force that common. So why do I say common? It means that it's usually existed in the question, but not always, okay? Not all of them is always there, but it's usually there. So whenever you see the question, please go through the list, okay? Just go through the list. There are 4 of them. Please go through the list to check whether is there the force there, okay? The first one is actually the most simple one, but a lot of people misunderstand it the most as well. This is called a gravitational force. Gravitational force, or simply we could call it the weight. Now, weight is something that we have heard a lot, okay? Weight is, for example, I have a weight, the table has a weight, you have a weight. So a lot of people would think, okay, weight is just how heavy you are, which almost correct, okay? How heavy you are is the force. The weight is a force that pulls the object down. Let's say my weight. My weight is how much force is pulling me down. Okay, something is pulling me down. The weight of the table is something pulls the table down. Your weight is something pulls you down. So the key is a weight of any object is going to be the force that pulls the object down. Of course, the question is, who is the one who pulls it? Because as I say, every force must be the one who acts and the one who acts. So my weight is I'm getting pulled down. But who is pulling me down? Oh, basically, who is pulling every object downward? So let's think, what is below us? What is like the thing that like pulls everything downward? And the answer is the earth. It's the earth that pulls us down. So whenever you see the weight, you need to realize right away, the weight is the force that the earth acts on an object. The weight is the force that the earth acts on the object. So the earth pulls me down. The earth pulls you down. So just imagine as like the earth is like a very buff guy. He go to the gym a lot and he take a rope and he wrap around me and he just yank me down. And basically he just yanked everything down. Okay? Now, another question that I kind of get is, does it have to be the earth? Could it be anything else? The answer is, of course, okay, it's just any big mass near us. Let's say if I happen to be on the moon, then my so-called weight on the moon is going to be due to the moon. Like the moon is pulling me down. But of course, in most cases, if not all of your life, in a lot of the question in IB, what you're going to see is they're going to be doing the experiment on the Earth, or at least on the Earth's surface. So it means that the weight of the object will be due to the Earth. Now, we need to draw the force properly. So how are we going to draw the forces? We're going to draw from the center of an object downward. Always draw it downward. So for example, let's say that there is a box. Okay, any object, maybe it's just a random box. If I'm going to draw it, I need to indicate it that the force is acting right at the center. So I'm going to make a dot and then just draw it down. Boom. So that's how I indicated the weight of this box. Okay. Of course, this is a vector. Force is definitely a vector, meaning that it has both magnitude and direction. So the magnitude of the weight is going to be represented by the length of an arrow. So a lot of people ask, well, then how long would this arrow has to be? Now, in the generic case that we don't really know how much is the weight of the object, we just could draw any length we want. But if in some particular case where you know that, oh, the weight here has to be greater than the other force, then you need to be careful about the length of the arrow. But most of the time, when we draw something like this, it's just it's like a placeholder to remind us that, okay, there is a force downward. We don't care about the magnitude, at least not yet. Okay? So just draw an arrow down, it's fine. The drawing that we just did here, we call it a free body diagram. So if the question asks, draw the free body diagram, that's how you draw it. Need to be drawn from the correct point at the center. Now, about the magnitude. The magnitude of the weight is actually quite easy to find. We can find it by using equation of weight is equals to mg. Okay. It's actually m times g. M is the mass of the object. The unit of the mass, hopefully you know that is given in kilogram. Okay. The g. Now, this is the place where students usually make a mistake. A lot of them say, the G, simple, G is gravity. No. In IB, we will never ever use the word gravity. Never, okay? Gravity is for kids. Okay, gravity is like for kindergarten. We're like the big boy now. We need to be grown up. Because in physics, technically, gravitation has a lot of terms associated with it. For example, gravitational force, gravitational field, and there is also gravitational potential and gravitational potential energy. So basically, if you say gravity, okay, gravity, you don't really know what do you mean. Okay, so you have to be very careful. The weight is gravitational force. It is the force. But this G is not the weight because it's not the force. G is called gravitational field strength. Gravitational field strength. Now, the gravitational field strength, it's actually quite hard, and we're gonna get to that, what it means later. But for now, just remember that it's called the gravitational field strength. Now, some people ask, is it the same as the acceleration due to the is it the acceleration due to the gravity? Is it the acceleration of free fall? The answer is yes. Okay, it's the same number. However, to be honest, to be correct, it should be called the gravitational field strength. Now, the value of gravitational field strength depends on where you are in the universe. But once again, most of the time, the experiment will be done like here, close to the Earth's surface. So we're going to usually use the field strength near the Earth's surface, which you know is given as roughly 9.81. Okay, 9.81 meter per second square. And of course, as I mentioned, this number happens to be the acceleration of free fall. So that's why when we calculate about projectile, about SUVAT in the previous topic, we also use this acceleration. But of course, the question could use this trick. Maybe they say, oh, the gravitational field strength on the moon is 2. Maybe let's say, for example, 2 meter per second square. Even though it says gravitational field strength is 2, you need to be reminded it means that the acceleration of free fall of any object on the moon would also be 2 as well. Okay? But this is simple. It means that you are able to find the weight of any object. Very simply, take the mass of that object times with the field strength at that point, or on Earth, 9.81. So when we draw the free body diagram, when we label it, we're going to label the weight mg. Okay, just mg, the weight. So I think the weight is actually the easiest of them all because we know which direction would it be and also what magnitude would it be as well.